Day 552 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3607, power grid maintenance. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer C representing C power stations, each with a unique identifier ID from 1 to C, 1 base indexing. These stations are interconnected via N bidirectional cables represented by a 2D array connections where each element of connections of I is equal to U of I, comma V of I indicates a connection between station U of I and station V of I. Stations that are directly or indirectly connected form a power grid. Initially, all stations are online and operational. You are also given a 2D array queries where each query is one of the following two types. 1x is a maintenance check is requested for station X. If station X is online, it resolves the check by itself. If station X is offline, the check is resolved by the operational station with the smallest ID in the same power grid as X. If no operational station exists in that grid, return -1. 2x if station X goes offline, i.e. it becomes non-operational. Return an array of integers representing the results of each query of type 1x in the order they appear. Note the power grid preserves its structure. An offline non-operational node remains part of its grid and taking it offline does not alter connectivity. All right, y'all, so I can understand how that may be a little bit difficult to understand. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input C equals 5, connections equals a 2D array of integers, first being 1, 2, then 2, 3, then 3, 4, then 4, 5. Queries is also a 2D array of integers, first one being 1, 3, then 2, 1, then 1, 1, then 2, 2, then 1, 2. The output is an array of integers 3, 2, and 3. So let's take a look at this explanation so we can see how they got this output from this input right here. Boom. So it says initially all stations 1, 2, 3, 4, and 5 are offline from a single power grid. So let me just copy and paste this over here so we could go through it visually. So first we look, the first query we have is this right here, 1, 3. It says query 1, 3, station 3 is online because remember, all stations start online right at the beginning. It says right here, initially all stations are online. So we come to query 3, station 3 is online, so the maintenance check is resolved by station 3. So it says whenever we see a query that starts with 1, it says a maintenance check is requested for station X. So X would be in this case, station X would be 3, but station 3 is already online, so we don't have to do anything because it says right here. So once again, X represents the station. So when we see a 1, if it starts with a 1, and then that means we're looking at station X, it says a maintenance check is requested for station X. So in this case, a maintenance check is requested for station 3 because our query starts with 1, and then we're going to, looking at station 3. It says if station X is online, it resolves the check by itself. And so since initially all stations are online, and this is our first query, then station 3 is online, so it's going to resolve itself like it says right here. It says right here, if station X is online, it resolves the check by itself. So it's online, so it resolved that check. But we need to remember, if a station X is offline, then the check is resolved by the operational station with the smallest ID in the same power grid as X. So we'll get to that as we continue, right? So right now, everything's running smooth. Station 3 is online, so it resolves the check by itself, so we could keep going. So now we keep coming down the line. That was this first query. Now we're coming down the line to the next query, 2, 1. Boom, it says query 2, 1. Station 1 goes offline. The remaining stations are 2, 3, 4, and 5. So if a query starts with 2, that means the station goes offline. So if the query starts with 1, then if the station is online, it resolves the check by itself. If station is offline, the check is resolved by the operational station with the smallest ID and the same power grid as X. But if it starts with 2, then the station X goes offline. So in this case, we're looking at 2. It starts with 2, so that means station 1 goes offline. And after station 1 goes offline, now it looks like this. So we could just get rid of this, right? Boom, because station 1 went offline, so we could get rid of it. So now we keep going down. We did these 2 queries. Now we're on this query right here, 1, 1, 1, 1. Boom. It says station 1 is offline, right? Because we just turned it offline here. So now station 1 is offline. And remember when it says if it's offline, if station X is offline, the check is resolved by the operational station with the smallest ID and the same power grid as X. So remember station 1 is offline because we just turned it offline here. So now it says so the check is resolved by the operational station with the smallest ID among 2, 3, 4, and 5, which is 2. So also it's important to remember that we are only returning integers of the results of each query that starts with 1. So we're only storing our output with for the queries that start with the 1. So this one, sorry y'all, I skipped this step. So 1, 3, station 3 is offline, so the check is resolved. That's why we added the 3 to our output. So let me just come down here for output. Boom. So we added 3 to the output right here. Oh, sorry, right here when we ran this query with 1, 3, right? So we added the 3 because the maintenance check was resolved. Now when we get here, station 1 is offline. So when we call this one, we want once again, we want or it says right here, the check is resolved by the operation station with the smallest ID. Since 1 is gone, then the next station with the smallest ID would be 2. So that's why we insert this 2 into our output. Boom. Because once again, this is a query that starts with 1. We're only inserting elements into our output for queries that start with 1. So when they start with 2, we could skip those. But if they start with 1, then we need to put in our output. But now let's keep going. We did these 3. Boom. So now we're on 2, 2. 2, 2. So that means, once again, 2x. That means station X goes offline. So since we're calling 2, 2, it starts with a 2. And then station 2, that means station 2 is going offline. So it says, query 2, 2, station 2 goes offline. The remaining stations are 3, 4, 5. So boom, station 2 is offline. Boom. Now it says query 1, 2. So once again, it starts with the 1. So we know this query is going to return something in our output. Then it says station 2. And then it also says, so station 2. And remember, station 2 is offline because we just took it offline here. So we're going to check is resolved. So the check is resolved by the smallest operational station with the smallest ID among 3, 4, 5, which is station 3 because 3 is the smallest, right? So that's why we put this 3 in our output because it says 1, 2, but 2 is offline. So we're going to the next smallest ID, which is 3. And so that's our output, 3, 2, 3. That's how we got it, y'all. I hope that makes sense. Just in case it didn't, let's take a look at example 2, right? Boom, let me get rid of this. So in example 2, our input C equals 3. Connections is a blank array. Queries is a 2D array of integers. First one being 1, 1, then 2, 1, then 1, 1. The output is the output is 1 and -1. An array of integers 1 and -1. Explanation says there are no connections, so each station is its own isolated grid. Then it says query 1, 1, station 1 is online and it's isolated grid, so the maintenance check is resolved. Boom, so we could add 1 to the output. That's how we got this output. Then we get a query 2, 1, right? Boom, so that lets us know we're shutting station 1, we're taking it offline. So now station 1 goes offline. Boom. Once station 1 goes offline, now we query 1, 1, but station 1 is offline. So it says station 1 is offline and there are no other stations in this grid, so the result is -1. Boom. So since there are no connections each station is in its own isolated grid. So when we take station 1 offline and there are no other stations in its grid, then we need to return -1, and that's how we got our output an array of integers 1 and -1. Boom, y'all. So I hope that makes sense. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. So let's get into it. Now, the first thing we're going to do is we're going to initialize the parent array for a union find, and each node starts as its own parent. So we're going to declare a variable called parent, and we're going to set that equal to an array, open up the parentheses of 0, ... C. Boom, just like that. Now we need to we're going to create a function, a find function with path compressions. Excuse me, y'all. So we're going to declare a func, call it find, open up the parentheses. We're going to say _x : integer. Come outside of the parentheses. We're going to return an integer. We're going to open up the brackets, and if x is not its own parent, then we're going to recursively find and compress the path. So we're going to say if parent square bracket x does not equal x, then we're going to open up the brackets and we're going to say parent square bracket x. We're going to set that equal to find, open up the parentheses, and we're going to pass in parent square bracket x, just like that. Then we come underneath this if, and we're going to say return parent square bracket x. Boom. Now we'll come outside of that function, and now we're going to create a union function to connect the two nodes by saying func union, union, open up the parentheses, we're going to say _a : that's going to be integer, comma, _b : that's going to be integer as well. We're going to open up the brackets, we're going to say let root square bracket, let root a equal find, open up the parentheses, pass in a, then we'll say let root b equal find, open up the parentheses, pass in b. Now we're going to merge the two sets by attaching one root to the other. So we're going to say if root a equals root b, then we're going to open up the brackets and we're going to say parent square bracket root a. We're going to set that equal to root b. Boom. And then we're going to connect all given edges by coming right here, and we're going to say for edge in connections, we're going to open up the brackets and we are going to say union, open up the parentheses, edge square bracket 0, come outside of that, comma, edge square bracket 1. Now we're going to apply path compression to flatten all parent relationships, and this ensures future finds are big O1 amortized. So we're going to come underneath this for loop, and we are going to say for I in 1 ... C. We're going to open up the brackets and we're going to say underscore equals find, open up the parentheses, and pass in I. Boom. Then we need to group all nodes by their root. So we're going to come underneath this, declare a variable called groups, and we're going to set that equal to a dictionary. So open up the square brackets, the key is going to be integer, the value is going to be a set of integers. So set less than int greater than, come outside of the square bracket and put parentheses like that. Boom. Then we're going to come underneath groups and we're going to say for I in 1 ... C. We're going to open up the brackets and we're going to say let root equal find, open up the parentheses, pass in I. Then we're going to come underneath that and we're going to say groups square bracket root, comma, default, square bracket, or a blank array. The default is going to be a blank array. Then we're going to come outside of that. We're going to say dot insert, open up the parentheses, passing I, just like that. Boom. Then we're not done yet though, y'all. We're just getting started. We're going to come underneath this for loop, and we are going to store the results for the query of type 1 by saying, first we're going to declare a variable called results. We're going to say colon, and that's going to be an array of integers, and we're going to initialize it by saying equals a blank array. Boom. Then we're going to say for query in queries, we're going to open up the brackets, and we're going to say let type equal query, sorry y'all, query square bracket 0. So remember that the type could be either 1 or 2. It's either going to start with a 1. If it starts with a 1, then we follow these rules. If it starts with a 2, then we follow this rule. Boom. So that's what I mean by type. Then we're going to say let x equal query square bracket 1, which will be the target node. Then we'll come underneath that and we'll say let root equal find, open up the parentheses, x, which is going to find this component root. Then we're going to come underneath this and we're going to say if type equals 2, we're going to open up the brackets, and we just need to remove x from its connected component by saying groups square bracket root, come outside the square bracket, question mark, dot, remove, open up the parentheses, x. Boom. Then we're going to come right here. We're going to say else. We're going to open up the bracket, and we're going to return x if still a component. Otherwise, we're going to return the smallest node ID in the group, or -1 if empty. So we're going to say if let group equal groups square bracket root, come outside of that, we'll say comma, group dot contains, open up the parentheses, x. We're going to come outside of that, we're going to open up the brackets, and we're going to say results dot append, open up the parentheses, passing x. Then we'll come right here, we'll say else, open up the brackets, results dot append, open up the parentheses, passing groups square bracket root, come outside the square bracket, x, question mark, dot min, put the parentheses, question mark, -1 for our default value. Now all we need to do is return the collected query results by coming right here, and we can say return results, y'all. That should be all she wrote. Let's give it a run, y'all. Let's give it a run. Okay, so we have a typo. Should get rid of this T. Let's run it again. See what that does. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 1,718 milliseconds beats 100% of users with Swift. That's what I'm talking about, y'all. That's what I like to see. So before we go, make sure you get one more look at the code. This is the top part. This is the middle part. This is the bottom part, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.